Today I am going to discuss about the universal gravitation, Newtonian gravity, free fall acceleration and the gravitational force in the space, and the gravitational potential energy and escape speed, Kepler's first law and second law and third law. Let me go for the next session. Newton's laws of universal gravitation. In generally, the Newton's law is explains about the gravitation on any two objects in the universe. The apple was attracted to the earth. All objects in the universe were attracted in the same way to each other in how the apple was attracted to the earth as shown in the figure. So because of the reason is the planet is revolving around itself and it is revolve around the sun. The Newton's laws of universal gravitation is depends mostly on the parameters like every particle in the universe attracts every other particles with a force that is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. And here if you observe, the forces is applied from one object to second object and second objects to first object. So there is an F12 and F2 which are the opposite direction with equal magnitude in the distances. The force that mass 1 exerts some force on mass 2 is equal and opposite to the force mass 2 exert on mass 1. The force from a Newton's third law, the law of action, will gives the reaction. The gravitational force exerted by a uniform sphere on a particle outside the sphere is the same as the force exerted if the entire mass of the sphere were concentrated in its center. For a free fall acceleration, let me go for. Have you generally heard these claims which are in below followings? Astronauts are weightless in space. Therefore, there is no gravity in space because there is no gravity in vacuum. So that's why there is no weight. It is true that if an astronaut on the International Space Station tries to step on a scale, the astronaut will weigh nothing. It may seem reasonable to think that if weight equal to mg, since weight equals to 0 because of g equal to 0, but this is not true. If you stand on a scale in elevator and then the cables are cut, you will also weigh nothing because ma is equal to n minus mg, where n is the normal force. But in free fall, a equal to g, so the normal force n equal to 0. This does not mean g equal to 0. Astronauts in orbit or in free fall around the earth just as you would be in the elevator. They do not fall to earth only because of their high tangential speed. Free fall acceleration and the gravitation force. Here, consider any one object of mass m near on the surface of the earth. Then it has acceleration due to gravity g, which is having 9.8 meter per second square. Let me go for the Kepler's laws. So in this Kepler's laws, all planets moving in elliptical orbits with sun at one of the focal point in its complete elliptical motion. A line drawn from the sun to any planet sweeps out equal areas in equal time intervals is called as the Kepler's second law. The square of the orbital period of any planet is proportional to cube of the average distance from the sun to the planet, which acts like a semi-major axis. Let me go for the Kepler's first law. All planets moves in elliptical orbits with the sun at one of its focus and the remaining is empty. Any object bound to another by an inverse square law will move in elliptical path like this as shown in the figure. So elliptical is having one of actually two focuses, but in one of the focus the sun will be located and the remaining planets are revolving around it. And the ellipse is depends on which parameters. In generally, the ellipse is depends on two parameters, that is major axis and minor axis. The distance of minor axis a is considered as the major axis ab by 2, and the distance of semi major axis b is equal to the distance between CD, that means which is acts like a minor axis, by 2. So that is the semi minor axis B equal to minor axis by 2. Distance from one focus to the center of the ellipse is EA, where E is the eccentricity. The eccentricity is 0 for the circular motion but very high for elliptical motion. Now let we go for the Kepler's second law. The Kepler's second law is always gives the information about a line drawn from the sun to the any planet will sweeps out equal areas and equal time intervals. Area of A to B and C to D are in the same nature. Now coming to the Kepler's third law. The Kepler's third law gives that the relation between the semi-major axis and time period. The square of the orbital period of any planet around the elliptical path is directly proportional to the cube of the average distance from the sun to the planet. Here T is the time period of the planet, A is the average distance from the sun, which acts like a semi-major axis. From orbit around the sun, Ks is equal to 2.97 into 10 to the power of minus 19 seconds square per meter cube. Here K is independent of the mass of the planet, which will gives from the equation 4 pi square by Gm. The mass of the sun, how we are going to calculate? Calculate the mass of the sun, nothing that the period of the Earth's orbit around the sun is 3.156 into 10 to the power of 7 seconds, and its distance from the sun is 1.496 into 10 to the power of 11 meters, where t square is equal to 4 pi square by Gm, which is Ks and A cube. Therefore, from this equation, m is equal to 4 pi square by gt square into A cube. By substitution of these values, we will get the mass of the sun 1.99 into 10 to the power of 30 kgs. This is the mass of the sun. Thank you.